and thank you for joining us today. We are here to share our joint journey, Elisa, Nokia, and Red Hat, which started in 24, where we started the collaboration to evaluate the maturity, impact, and benefits of our joint 5.3 Cloud Run implementation, and then how we compare to the Elisa's traditional legacy radio network. So in this session, we will share the benefits and of course challenges of the pilot, what we are doing, and then really status update about the live pilot which is ongoing. So let's get started and let me introduce the fellow speakers. So with me today we have Timo Sippola from Nokia, Matti Svan and myself. Let's start with a quick round of intro. So Timo, if you start, and then Matti and I will conclude.
Okay, thanks Aki. Hello everyone. My name is Timo Sippola and I'm product manager for Cloud Run in Nokia. So Nokia radio side called Mobile Networks.
Yeah, hi all, Matti Svan, lead architect at Elisa, and my focus is on mobile core technologies and codification of telco workloads.
Thanks. So my name is Aki Pellinen. I work for Red Hat. I'm a senior solution architect for telecommunication based here in the sunny Finland. Good. So here's the quick agenda which we are covering today. So we have a Nokia corporate update, then the Cloud Run solution update from Nokia, and then Matti is going through the Elisa Huawei, and then where we are on the Cloud Run pilot status and update and what's happening in the future. And then my goal is to basically providing a quick update about our Red Hat solution and how do we support the Cloud Run pilot and the roadmap going further. Good. So that's the scene. So Timo, if we start with your section first.
Thank you. So first some words about Nokia. Nokia is a major network vendor. So we are involved in all kind of connectivity what comes to traditional telcos in terms of mobile networks and fixed networks. We have expanded our offering to data center networks and private networks. We do also software offering for operating and automating these networks. Cybersecurity these days is one of our strong focus areas. And then recently we have also expanded to non-terrestrial networks, meaning satellite communications. That's all about Nokia in general that I wanted to share, and let's go then to the Cloud Run topic. That is the agenda for today. So here we see kind of higher level picture of Nokia Cloud Run offering together with Red Hat OpenShift. So the blue box below shows that we have a so-called Nokia Cloud Run blueprint, or nowadays we call it reference architecture also. So there we might have data center hardware deployments from different hardware vendors. That is then cloudified using Red Hat OpenShift. And on top of that, we are then running Nokia applications for Cloud Run specific elements like VCU and VDU, as well as then other applications that play well together with Cloud Run like RIC and so on. Then depending on these use cases, we might have then a different location where we have these applications running. VDU is always closest to the radio. There we have strict latency requirements, but then other Cloud Run components, they can be either co-located with VDU or more centralized located to achieve then maybe higher centralization and pooling gains and so on. We are also having Red Hat OpenShift as part of our core network deployment, similarly to our run part. And then in next slide, here we go a little bit more to the details. What is the current Nokia offering for Cloud Run? So we have, if we start from the left, where we have this radio access network RAN. Closest to that, we have the VDU. That is in this kind of distributed single node type of deployment at the moment. There we might have different capacity options that is then scaled up as number of servers and Nokia Cloud Run SmartNICs. SmartNIC is used for layer 1 processing, and it's also very efficient to achieve full feature and performance parity together with traditional or classic radio access network. And here we see with red color that we have Red Hat OpenShift playing a key role to cloudify and giving a cloud platform for Nokia video application. We can have VCU also co-located with VDU there in distributed model, but more sophisticated way to deploy VCU is centralized VCU, where we are then achieving through cloud native type of multi-node cluster solution together with and supported by Red Hat OpenShift as shown also here. And there we then get through pooling gains and other factors that we are looking via Cloud Run solution. In next slide, there we have then kind of more wider view to Nokia Cloud Run solution overview. Cloud Run solution overview. So that if we start from the bottom, there we see that in Nokia Blueprint we support at the moment Dell and HPE data center hardware. That is then running below Red Hat OCP. So there we have Red Hat providing cloudification for Nokia applications. In Blueprint solution, hardware management is provided by Nokia. CAS layer or cloud automation, that is together with Red Hat. And then this cloud native functions lifecycle management, that is provided by Nokia. We also, for openness, we are supporting basically or enabling any other hardware vendors or web scale based hardware layer. There could be other CAS layers, CAS vendors used. The key requirement from Nokia perspective is that we have this Nokia 5G applications, VDU and VCU running on top of the cloud platform. We have some lifecycle management from Nokia, but basically the rest could be provided by the third parties. And then, as I mentioned already earlier, Nokia SmartNIC is playing a key role to make sure that whatever solution we have there for Cloud Run, we have full feature parity and performance from Nokia perspective when we are comparing to our classical radio access network offering. So Nokia Cloud Run solution is built on industry standard hardware and with the partners. And with this, I would like to then let Matti to continue and explain and tell you what we have done together with Elisa using Nokia Cloud Run solution.
Yeah, thanks, Timo. So Elisa might be a new name or new company to use. So just a short company introduction. So we are a Finnish company We provide telco and digital services in Finland and Estonian markets, and we have developed a lot of in-house automation tooling and also processes over the decade or so. So in addition to this telco business, we also offer a portfolio of different automation solutions for the telcos and manufacturing companies as well. Now, my own area of expertise is more on the mobile core and clarification of telco workloads, but today I do my best to cover also the radio part. Now, we started our clarification journey of the telco stuff around 2050 with OpenStack environments, and today our mobile core plus many other network functions, they are actually now running on bare metal Kubernetes platforms, and now we are also migrating the remaining VNFs from OpenStack environment using KubeVirt technology. We plan to shut down the OpenStack environment by the end of this year. But when it comes to access networks, and especially radio network clarification, so there we are still at an evaluation phase to find the business case to justify that move. Let's go into the, thanks Aki, into the actual pilot setup and background. So we started the evaluation almost 2 years ago as a lab pilot with the pre-commercial software from Nokia, and this phase was then extended to a live trial in October last year. And the setup now includes 4 radio sites at the city of Espoo, and each site has 3 5G NR TDD 3.5 GHz radios connected via eZipri connections to a local cell site router. And each cell site router has a 100 gig connection to the local aggregation site. And recently we also added this 5G FDD 700 MHz cells, which need a separate front haul gateway to perform this legacy Zipri to eZipri conversion. So at the local aggregation site, there are actually 4 single node OpenShift clusters hosting the VDUs with these smart NICs Timo mentioned. So there's currently a 1-to-1 mapping between the radio site and the VDU cluster. And the VDU cluster is located at our central data center, and that's a multi-node OpenShift cluster. And then our IP core network connects all these functions and sites together, so and also provides synchronization for the radio stuff. Now we also deploy Nokia's management tooling. So obviously we are using the Nokia Mantere, the Nokia's network management system, which we also upgraded to support these Cloud RAN software releases, and we also added a couple of other Nokia's automation tools. So for example, this NEAT, which stands for Nokia Edge Automation Tool, which manages the radio application lifecycle. And also we added a second component from Nokia called Nokia Data Center Manager, which manages the compute part via Redfish API. Now in March, as part of Nokia's new software release, we included Red Hat's Advanced Cluster Management, ACM, to automate the cluster lifecycle management. And we also included the capability for faster VDU software upgrades using this image-based upgrade model with the VDU seed unit placed at the central data center. Now, so far, the focus of this exercise has been on measuring the performance and quality of the Cloud RAN based deployment compared to the classical radio one. So, and based on the daily reporting we are doing with Nokia together, we can confirm that the performance and quality are at the same level. Okay, so right now we are still very much in evaluation development phase. So not all the features what we are looking for yet supported by Nokia. So we continue and expand and modify the pilot as needed. So there are many things still to consider, and I highlighted some of those items in this slide. So starting from the left side, So there are different options how to implement the radius site. You could simplify the site installation by placing the radius at the cell site and placing the VDUs at an aggregation edge site. But this puts limits to the distance one can have between the radius and the VDUs. And in practice, you also need a 100 gig connection to enable that, which can also be a major upgrade to your network, which, for example, in our case is because today we are using 10 gig connections for the 5G radio sites. Now for locations outside the bigger cities, those might be limited with aggregation network capacity. So in those locations, you might consider placing the VDU or the baseband unit at the cell site also. So in that case, the 10 gig connection is sufficient, obviously. Now, one capability we are looking for is the VDU pooling, which means that you could share the VDU capacity among several radio sites. So instead of having this one-to-one mapping between the radio and the VDU, so you could save some hardware capacity in that case. And also the video pooling should improve the end user experience due to improved interference mitigation. And that's kind of promising benefits. So these are all promising benefits, but we need to calculate if it can justify these aggregation network upgrade costs once we have been able to verify these quality benefits in practice. Now moving on to the VCU side, so you can expect to have some moderate pooling benefits there as well, and it's also a natural place to host a UPF, a user play function, to enable local breakout to local services if you are providing those, or for enterprises to access the local data centers. Or if you want to minimize latencies, then you could also place the VCU and UPF together with the VDU at an aggregation edge site. Then moving on to the central site deployments and perhaps the most important area, the automation. So first of all, we need automation to hide the complexity of the cloud RAN. I mean the functional disaggregation, the radio, the VCU, VDU, and the virtualization. So to get the same level with classical RAN deployment what we are having today, and then even go beyond that level of automation. And in addition to automation, observability is very important due to the same reasons. So we need to be able to visualize how the traffic from a single radio site gets processed in a network and correlate the faults and do even eventually some preemptive fault management, what we can already do today with classical RAN deployment. So the impact is not only technological, but it also has a big impact on the current processes what we have today. So acquiring competencies and how to operate the network, which KPIs should we follow, when to increase radio site capacity, and where to actually place the capacity on the radio site or the VDU, VCU. And there's also need to educate or even source new subcontractors to deal with this cloud RAN deployments. So many things to consider, many operational things to consider. And then there's also this cost-based performance aspect. So when you add more companies to the stack, so they all want their share of the pie. So Nokia wants money from radio licenses, Red Hat wants money for the OpenShift licenses, and compute vendor wants money from the compute hardware. So margins can be quite tight. And price performance ratio of these COTS x86-based systems with these smart NICs, so those needs to be at least at the same level as the current purpose-built baseband unit prices. And a final point, so the service continuity. So once there are tens or even hundreds of radio sites connected to the VDU or VCU cluster, there has to be a way still to do upgrades and patching and recover from network failures without having any major impact to customer traffic. So that's all from my side, and then Aki to continue your Red Hat activities.
Thanks, Matti, and thanks, Timo. So basically, how do we stitch everything together? So clearly, what I've highlighted in the slide that we are the platform supplier for the Cloud Run and also the cloudified core, and we are partnering with our solution providers and customers like Elisa and Nokia. And basically, what we see a huge value that we need to enable them a baseline for the innovation, meaning that they can get well integrated, tested, and stable environment, which enables them to scale the mobile requirements. Like Matti was saying, the baseband spooling, the VDU, shared baseband, and these things. So this is the things that we need to enable on the platform side. And then everything comes in the picture that we have a good, solid reference design for the DU and CU designs. And that basically also enables them a life cycle capabilities and managing these services. Then also where I see a huge requirement is the cluster compare and really making the design in a way that it's repeatable and scalable, but also manageable. And we are providing tools to really looking into so-called drifts between the OpenShift cluster configuration to really look into that this uh, radio cloud instances are following the best known methods and are actually up to date for the requirement perspective. Then second thing is that on the top right corner is to really looking into the hardware enablement. Like Timo was saying, the L1 accelerator from Nokia, that's the key thing, that we make sure that all the drivers and everything is certified by our OpenShift. And of course, lifecycle, because then we are enabling the best and breed technology for Elisa to really make the comparison between the traditional RAN and the Cloud RAN benefits. And that's our key thing. So, for example, these key elements for real-time kernel, precision timing protocol, SRIOV, DPDK over SRIV, all these fancy stuff we all telecom nerds love from since 2015, more than 10 years ago. And then if you think about the CPU enablement, we really want to work with AMD. And for example, the Sapphire Rapids EE and the Sapphire Rapids SP, we are really working closely to enable them. And then for the VDU designs for Granite Rapids D, for example, is a good example, with the PTP capabilities. But not forgetting the new players. For example, the NVIDIA Grasshopper as a validated architect in the future for example, the AI RAN perspective. So innovation is continuing heavily in there. And not forgetting, for example, the network interface cards, the E810, for example, from Nokia. Then the third one, the operational improvement. So as you see in the diagram, single node OpenShift is playing a critical role on the VDU design. And how do we life cycle? How do we do refresh capabilities? How do we do failure and analysis? And how do we recover from possible issues there? So that's why we are looking for the shift left. When I have a slide on that following that, which is very detailed, which we don't going to go over today, that detail. But as I said, we are here to for follow-up questions or anything like that, and the contact details were in the beginning of the slide. So basically, goal would be that the image mode is enabling for a quicker deployment capabilities and less effort at the edge. So really utilizing the image mode at the full edge then. So then last but not least in this slide is how do we do with the O-RAN Alliance? Meaning that the O2 interface, which is defined by O-RAN Alliance, is key thing for making the infrastructure as a code really enabling its promises. Meaning that you can actually have the O2 DMS interface through to our container APIs for deploying and managing the hardware also. Today we are doing that through Redfish. That's a really good start because that's enabling the hardware ecosystem to really looking into the software aspect, how to manage it. Good. There's a lot of reference material in the below where you can click for our DU design and then the core reference design will be published publicly. Good. So next, so this is what what I was providing a quick hint about shift left. So what do we mean by that? That we actually are preparing, it's in a nutshell, we are preparing everything through GitOps and automation. The key things what Matti highlighted also in the future steps. This is the one where we also see a huge improvements that when you deploy once, you can scale it tens of thousands of times. And then it gives you the ability to really look into the capability of managing, upgrading, and life cycle in your product. Good. So moving on. So zero trust provisioning. So you have probably heard me saying several times about the infrastructure as a code. So this is what I mean by that. We have a central of truth through GitOps, meaning that the GitOps way of managing the hardware, the CAS layer, and also the CNF. So basically looking into the whole life cycle management scalability through CAS layer in that sense. And the key thing here is the AAP, Ansible Automation Platform from Red Hat. This is like in integral partner in the future for automation, and in my mind, this self-healing and self-scaling network where AI is doing all the work for us, and we are enjoying the summer and good time off. But we are not there yet, so that's why we still are here. So basically, this is a block diagram about the actual process of it, which is now overlaying the things what we see in the future also with Elisa and Nokia Cloud Run Pilot. Good. All right. So basically, what we did, we announced 419. So these are the key deliverables what we are bringing on that, and basically 3 focus areas. So continued improvements of OpenShift Platform Plus. That's the key thing with the latest and greatest RHEL 9.6, and then for roadmap items I have a slide for that. And then one of the key things what I mentioned, the image-based break and fix. That's the key thing. And then last but not least, I see a huge benefit of event-driven Ansible. What I mean by that, if we see any abnormalities based on the data, on the capture what we do, we can actually react that automatically, or we actually flag that we have seen this issue for the operation people to take actions. Then in the middle, now of course the reference architecture specification of that, that's the key thing for 419, but in the middle, we need to enable also the ecosystem. For Nokia's, the Ericssons, the Samsungs, and everybody to really see the benefit of cloudification of RAM and really providing innovation top of the cloud run capability. So looking into the registration of single SMOs, the O3 interface, of course, and then looking into templating the infrastructure. That's the basic steps for infrastructure as a code going forward. And then hardening the SNO, single node OpenShift capabilities, and then enabling the alerting, which enables then the event-driven automation, and then we can get automated processes. Then looking into 419, the Granite Rapids D is there now, and NVIDIA Grasshopper is on there actually as a technology solutions for the 419 to be tested. Then basically conclude and the roadmap and summary in that process. So what do we do? So I just wanted to highlight that. So what we are doing, working with the SMO and RAN workload agnostic for Cloud Run components. That's the key thing. The one thing what I see a huge value is the hub cluster functionality to manage the cars and hardware as a Cloud Run project. And this could be also like Timo was saying that we are using OpenShift also on the core side. The hub cluster functionality, the deployment, the lifecycle of the clusters could be enabled on the whole telco cloud end to end. Of course, continue operator reference design, making people able to innovate quicker, ensuring that we have certified hardware suppliers. We have a best known methods to deploy clusters and lifecycle and scale them. So what are the key roadmap items for 6 to 12 months? So MetalQ, that's the one of the open source project, which we are basically enabling the bare metal host manageability through the Kubernetes API, which is natively supported. Then if you think about of course, the day-to activities, like Matti was mentioning that the service windows are small, and if there's happen any issues at the edge or the radio side, the implication needs to be quickly managed and fixed. So image space upgrades, image space installations are the key thing going in the future. And in my mind, one of the key things which I always want to highlight is the observability. Data is king, and the more data you have, the more fact-based decisions you are able to make, and then really get top of what's happening in the network. So is one of the key things for our really looking into supporting the best practices. So then use cases, SNO for DU profiles, multi-node OpenShift for RAN workloads for the CU design, and then of course Rail 10. So Rail 10 is actually one of the biggest innovation what Red Hat has been doing last 25 years since or more since we start doing enterprise Linux. So we are bringing AI capabilities and all of these good stuff also on with the Rail 10. So stay tuned for those. Then of course ecosystem. We really need to be a platform supplier for all the ecosystem to really looking into the innovation, because we are the platform supplier providing the innovation engine to our customers. And then, of course, cloud native best practices. We have seen that there's really nice optimized RAN solutions which are vertically integrated. How do we enable the ecosystem to really get the cloud principles also at the cloud RAN area? Good. So, concluding, a couple of slides here. Our solutions are open. So we have open telco sites here which you can click into and look into our solutions and our platform capabilities. So feel free to use it. It's free of charge. And of course, we want to have a good glimpse that, okay, we have done a quite good work with the three of us team. And I really want to highlight that the innovation still continues. And this is the beginning of our journey in that perspective. And I see a huge future with Elisa and Nokia together to even go deeper on and wider with cloud and technology. So this is a good example of what the press announcement was earlier. So then, last but not least, thank you on behalf. So guys, if you would like to have one final words on my behalf, thank you for your attention and looking forward to hearing from you. Timo, Matti, anything you want to do to conclude?
Thank you, Aki. It was excellently summarized. So nothing to add from my perspective. Thank you.
Yeah, thank you, Aki. Me neither.
Thank you for listening, and thank you for our co-presenters, Matti and Timo.
Thank you.
Thank you. Bye-bye.
Bye.